Hello, everyone. So today we are going to be looking at one specific multiplication strategy that I think is a bit spicy, a little bit more complicated than some other strategies, but still really valuable to learn. It's called the distributive property multiplication strategy. So the big question we have to ask ourselves is, what is this strategy? That's our question. So we're going to start off with that. So our first kind of what we're going to cover first is the definition. So any number, so a number can be decomposed or split up into a statement of addition, and then the pieces can be multiplied by the multiplier to get the same product. This sounds more complicated than it actually is. Um, so let's kind of take a look at how this works in in actuality. Okay, so we're going to look at a very simple statement. Let's do 6 times 3. We all know what this is. If we know our 3 times tables, we can definitely do this. If we know our 6 times tables, we can definitely do this. We know that 6 times 3 is 18. But what this strategy says that if you take the 6 and you decompose it or split it up into an addition statement, so it could be 1 plus 5, or it could be 3 plus 3, or it could be 2 plus 4, whatever you'd like it to be. I'm going to just do 3 plus 3. Then you can multiply each of these numbers by the multiplier, which is our 3, and still get 18. But how does this actually work? So what I want to do now is I want to go through and show you how this would work. We're going to start with the visuals, okay? So we're going to start with this one here, and I'm going to make this red. We're going to start with a visual here. So what this means, this statement, 3 times or 6 times 3, is a group of 6 3 times. So let me draw that out. I'm going to use lines because it's simpler. 1, 2, 3, 4, 5, 6. Got that? That's 6. 1, sorry, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 4, 5, 6. Okay, so this is, sorry, not writing well. There we go. So this is one group of 6, another group of 6, and another group of 6. There's 3 of them. So we have a total of 6 plus 6 plus 6, which gives us our 18. Okay, simple. Now let's look at this decomposed one, and I'll make this blue. Let's look at this decomposed approach. So we're going to do this represented in a visual looks like this. We have 3 plus 3, 1, 2, 3. We have this statement 3 times. So I'm going to do that 3 times. 1, 2, 3 plus 1, 2, 3. And then 1, 2, oops, 2, 3 plus 1, 2, 3. So I did that statement 3 times. Now I'm going to apply the multiply by 3 to this. Okay, so let's see. So here we have one group of 3, a second group of 3, and a third group of 3. So it's 3 times 3. Here I have one group of 3, a second group of 3, and a third group of 3. So we have 3 times 3. So in total, when we add them all together, we have 3, 6, 9, 3 plus 3 plus 3, plus 3 plus 3 plus 3. So we have 9 plus 9, which gives me my 18. Pretty simple. And notice it's the exact same as we knew it would be. So let's take this and let's actually show it algebraically. So what do we have? Well, we have 3 plus 3 times, plus 3 plus 3 plus 3 plus 3. Okay, so what this statement says is 3 plus 3 times. So I did that down here. 3 plus 3 plus 3 plus 3 plus 3 plus 3. Now, because of the way addition is, all of this is addition, so it doesn't matter what I do first. It's 3 plus 3 plus 3 plus 3 plus 3 plus 3. We know that multiplication is repetitive addition, so we know it's 3, 6, 9, 12, 15, 18. So we know it's exactly 18. So what have we really done? What has the distributive property told us? Well, it has told us the following, that when I decompose one factor into an addition statement, I can still apply the multiplier. And I can represent this for myself by going 3 times 3, which equals 9, and then 3 times 3, which equals 9. There we go. And then when I add 9 and 9 together, I get 18. So this isn't necessarily something you want to use on such a simple question, right? The 6 times 3 is very simple. We wouldn't want to use this on a simple question, but we could definitely use this on a more complex question. So let's try to use this on a more complex question. So let me just put a line here, and let's use it on something a little bit more complex. A double digit multiplied by a double digit, kind of different, but still valuable. So I'm going to take the number 17 times 13. We might not do the visual representation just because it'll take too long. So I want to show you what this would look like. So I'm going to cut 17 up into 10 plus 7. We all agree that 10 plus 7 is 17, correct? Good. Then I'm going to cut 13 up into 10 plus 3. So this distributive property basically states that I have 10 plus 7 10 times and 10 plus 7 3 times. Very interesting. So let me write that out using our numbers. So here we go. 10 plus 7 plus 10 plus 7 plus 10 plus 7. Sorry. Plus 10 plus 7. 1, 2, 3, 4. Plus 10 plus 7. I'm going to go on the other line because I need to keep going. Plus 10 plus 7 plus 10 plus 7. You know how annoying this is? Plus 10 plus 7 plus 10 plus 7. 4, 5, 6, 7, 8, 9. Plus 10 plus 7. And I need to do it 3 more times. Plus 10 plus 7 plus 10 plus 7 plus 10 plus 7. Whew. Okay, so what does this mean we have? Well, in the first 2 rows, I have how many tens? Well, I have 10 tens. That gives me 100. In the first 2 rows, I also have how many sevens? I have 10 sevens. 7 times 10 gives me 70. Super easy to calculate. In this row, the third row, I have how many sevens? I have So how many 10s do I have? I have 3. 3 times 10 is 30. And then how many 7s do I have? Well, 7, 14, 21. Super easy. Now I can easily add these up. I know that my 100, 170, 200, 221. So this equals 221. Now, you don't, the great part about this strategy is you do not have to show all this addition. This is just to prove that the strategy works. Let me show you how you can do it very quickly. So again, we have 17 plus 13. Let's split this up. Plus 7 times 10 plus 3. So what I'm going to do is I'm going to use my red and I'm going to distribute the 10 through. So 10 times 7 is 70 plus 10 times 10 is 100. Now I'm going to distribute my 3 through. 3 times 7 is 21 and 3 times 10 is 30. So what is my total then? Again, super quick and easy. I have 100, 170, 200, 221. So that is using the distributive property. Why does this work? That's the key. Why does this work? Why? Because multiplication, if you look here, multiplication is just repeated addition. And we know that when you break up a number into its component parts, you're really just adding again and again and again. That's what multiplication is. That's why this works.